Hello, everyone. We are very happy to be at the conference Berlin Buzzwords again, and we are glad also to present for the first time for both of us at this conference. So today we will talk about how can we make coding assistant and coding agents better with the search and very more efficient with better retrieval. So a little introduction about who we are. I am Amine Gani, and with my colleague Roudy Khoury, we are both software engineers and also search engineers at Adeline. We are based in France, and we are experts in search technologies. We do integration of Elasticsearch, OpenSearch, and Solr principally, and we are also interested in all the other search engines as well. We provide consulting and training for our clients and partners. And we are also developers of A2 e-commerce solution and enterprise search solution that we integrate for our clients and all cite the collaborative search engine. So before we dive into the search for coding agents, first of all, why the coding agents work so well? And it's simply, the simple answer is that the software is something that we can verify. So it's a domain that is verifiable. Not like the natural language tasks, for example, where the answer can be vague or expressive and depends on the intent. The coding agents have tools to verify what he is doing, and when we have a failure or an error, it is something that he can observe easily. So he can find informations for his context, build it, for example, compile the projects, launch some tests, and if it's not good, he will do an iteration, and he have a feedback loop where he can always try to improve by iterations. So this is why coding agents works at the first place. It works very well on demos. We use it every day, and we think that is adopted by almost every developer now. But we see that on large products, sometimes it is very complex to use them, and it does not work very well on the first try. So why they are breaking in the large repositories or big projects or legacy projects? Simply because sometimes when the agents look for a file or he plans his modifications, he will gather information that he needs for the tasks, and maybe he can have the wrong file. Simply for if we have a deprecated API or deprecated functions and classes, if we take Java, for example, or if we have legacy code that is not used in production anymore, but just with a feature flag to ensure the transition of deploying it in the new version, he can have maybe the wrong file here. For example, he will have the authentication with the legacy code instead of the second version. And also, he can also have everything in the context, but he should filter the context to have the good files. So he will reason to filter the noise on the context, and in general, it's a prompt waste for us. And we are not talking about hallucinations of LLMs in this case. We are really talking about retrieval errors and retrieval that is not very reliable for the agents. So we think that it's a problem for reasoning, but in the reality, it's a search problem. So, and every time we talk about these subjects with other people, they say, oh, it's okay, we have bigger models, and we can just throw a bigger context on the model, but it does not really solve the problem. So, for example, we have the latest models that are better. It is true that the models have better reasoning, and we have better models each time, but we see also that if we have, for example, 1 million contexts, if we throw everything in the context, we don't have really the information that is ordered by the retrieval. So, for example, here, we will have the tests and the mocks that dominates the code in production for a critical part, for example, but we will have the definition and the implementation that is buried in the noise of the context. And we all know the lost in the middle, for example, or the dump zone of the context. So initially, when we ask the LLM for something, he will forget maybe if we add a lot of context on it, he will forget the initial instructions, or he will just keep looping to find the good information before starting it. So when we add a lot of information in the context, he will be sent in every query to the model. So the latency will go bigger, and if I wanted to do, for example, some pair programming sessions with the LLM, it will not be fluid as before, because I will send each time a big context, and if I wait each time 1 minute or 2 minutes, for example, for the response, it will not be as fluid as I want. And we have also the token that are sent in each prompt, so the costs will also go bigger. So it's not really a solution, a reliable solution, to just say we have bigger context, so we can send more information in it. And when we are using the coding assistants, we noticed that they use Grep a lot and in a very efficient ways. Just to be clear, this talk is not really against Grep, because it is a very great comment that the model use in a very perfect way. If we had discovered some syntax that we don't even know that they exist in Grep, so it is very exact. It is perfect to find where this text appears or where this regex appears in the code. It is very fast, and so it is cheap also. But the problem is that the model needs ranking. So it needs evidence and ranking in the context, so that we know what is the important code or the good snippet here, so that I start to work, and after that I will, for example, fix the tests later. And if we look a little bit before, when I started to code, I remember at university, for example, even when I coded before, but at university, I wrote the code in the papers. And after that, we started using code editors. I was, oh, it's great, because I can now just open in the code editor the structure of my code. I can navigate between functions. And even our mental models is written the code not as text, but as relations, as structures. So the definition, for example, of the functions is important. And after that, I will see the dimensions of this function, where it is used, how I use it, and I will see also the tests, so that I know why I use it for, and I will not derive. So this is why we think that Grep is a very great tool, but it is not enough for the coding assistant to search code.
Okay, so we saw with Amine that reliable coding agents need high-quality retrieval. So let's look at a couple of retrieval methods. We'll start with the simplest one, grep. So grep will look for exact matches or occurrences of the user query in our code repository. It will also use like regex patterns to do the matching. So it's an extremely fast way to do retrieval, and it's a low cost. However, the main drawback here is that we don't have ranking, and we don't have the concept of importance between the retrieved snippets of code, for example. If we take an example, if a user asks a question about Elasticsearch, let's say, so the agent will do a grep search on the word Elasticsearch, and also its derivative, for example, Elastic or ES, and all the other derivative. And let's say Elasticsearch is used in 2 classes, but also in 30 unit tests. Given that we have no ranking in grep, we may have, for example, the unit test that comes as top hits. So in this case, our code agent will look the files one by one, starting by the unit test, which sometimes is irrelevant to the user question. So this way, we are adding a noise to our context, and we are consuming more tokens, because we are looking at a bigger chunk of code. So the next one, lexical search. Here we can say that it's like grep, but we add the ranking to the search result. And by doing that, we can optimize how our coding agent will try to search to solve our user query. However, here we need to maintain an index with our data. So we need an infrastructure like inverted index database to store our code repository. And also another drawback is that we should maintain our index up to date with code changes. For example, if we change code, we don't want our coding agent to do queries on some stale code or code that doesn't exist anymore. And also here the lexical search does not understand semantic, so the user query must have some identifier or like symbols to begin with. Okay, and the next one is structure and graph source. So here, actually, code is not just a text to do just lexical matching. Code is a structured data. For example, us like developers, we think about the classes, the functions, symbols, loop, stuff like that. So we can make our agent a bit like think like us. And to do that, we can use LSP protocol, which is used by many IDEs. For example, if we search for a function in any IDE, we can find its usage, where it's defined, all the data or metadata of each function. So here we are passing information as a graph to our coding agent instead of just chunks of code. The next one is semantic. So in a context where we actually know what we are looking for example, we know which parameter we are looking for or which function we are looking for. Actually, with the method we just saw, it should be okay. We don't need to use the semantic search. However, when the user query contains just natural language, it could be a question, for example. Here we need the semantic in order to retrieve like the code which can solve our question. But here it's more expensive because we'll probably need bigger infrastructure and also need an embedding model in order to generate our vectors. So as a summary, so each method excels in a specific use case. Let's say, for example, Grep, as we saw, it's best for exact matches, and lexical for exact matches also. But when we have identifiers or concepts in the user query. And the semantic, it's mostly used when the user query it's all in natural language. And after that, the structural code it's used for code navigation and finding usages and definitions. And the hybrid search, it's maybe a combination of multiple use cases.
Okay. So that now that we saw the different types of retrievals that we can use, we took a look at the big players of the domain or the biggest coding assistants that are used nowadays, and we wanted to see what are they doing. So what are they using and how the market is shifting today to know what they are working on. So the first things that we noticed is that there is a market shift with the coding assistants that were using Grep essentially to find code. We saw that a lot of companies start to using retrieval stack for their coding agents. So, for example, for the enterprises where the code is on their servers, it works very well because they can index data on the servers, but also on the code that is used locally, that is written locally by the coding assistant. So the first shift is that they are started using semantic search. So we have GitHub Copilot that published recently that their coding assistants were better by 12% for cursors, by 12% when they added semantic search to the coding assistants. And we have also GitHub Copilot that released some benchmarks. They are not just working on using new models, integrating new models and better models, but they are also releasing new embedding models for the code that they are using to search for the code when a person asks for a task, so they have benchmarks for code retrieval. So when we talk with the LLM to ask a questions about the code or to find something, the code retrieval is better than before than the previous model. And also when we are using this model in the agentic workflow, the agentic coding retrieval is better also. But there are some drawbacks, so they need to index the repository and they need also to maintain it. So Cursor used the turbo buffer search engine because they allow them to have several namespaces in vector search, so that they can use index every repository separately, and they are also optimizing the indexing by using the same chunks if the code is similar between projects, to not to have to reindex everything at each time. And so the constants here is clear. With better retrieval, we have better agents. And we also noticed that they are not using only grep or glob anymore. They are also using structure-aware navigations. For the best example here is Cody, the coding assistant from Source Graph. For example, we can see that we can search for a repository, for example, for a specific files. And for a specific functions, we can see that we have the definition of the function. Of course, we can be in precise mode, so we will only have this function in this file, but in the search mode, we will have the definition. We will use the tool that is go to definition to find the definition of this method. So we have it in 2 different files, and we can also navigate to see the reference, so to know where this function is used. And if we modify this function, we can automatically detect the impacts and know that we should modify the 12 references also. And we can also tell if we work only on specific locations, on a specific module, we can always filter by location. So we will just give the model the context that it needs, and we will not search in all the repository and add more noise on the contexts. And we also, if you see the Cloud Code documentations, the claim is very clear. They are using glob and grep, but they also have a tool called LSP tool that activates the language server protocol, and they say that if you use it, the model can connect to an existing language server protocol, so he can use the methods, go to definition, go to find reference, etc., etc. And if you use it, the model will do only one loop if he changes the method, and he will change the reference also. He will not do the change of the function, and then we'll build the projects, we'll find the errors, and then do a second iteration to fix the impacts on the reference. So we win time with this tool if it is enabled, and the model is also smarter because he can navigate this structure. And we are not, when we talk about retrieval, all the big players are investing heavily in the retrieval part, and it's what they call context engineering. So it's like the prompt engineering, now it's the context engineering. So we see that the retrieval is a part of the context assembly. And in Source Graph, it is very clear on their documentations. They use the search as multi-step pipeline to search information, to gather the information with the keyword search, semantic retrieval also, the code graph, and they assemble everything into a context assembly before sending the task to the LLM. And for example, Cursor are also doing some benchmarks. So here we see the Cursor context benchmark. The interesting things here is that they keep the same model, they keep the same task, they keep the same repository and everything. They change only the retrieval. And what is interesting here is that with changing only the retrieval, with adding semantic search onto their retrieval, it improves all the models. There is no exceptions. So we invite you to see this benchmarks, and we have the links in the slides. And it's very clear that the big players now are investing in the search, their search pipelines, and it's very important to have a clean context.
Okay, so I prepared a quick demo just to show a comparison between some retrieval methods. So in this demo, we tried to isolate the retrieval part of the LLM or the coding agent from the reasoning part. I will try to share my screen. Okay, and I will need that also. Okay, so we built an MCP server that provides a couple of tools, like one tools for indexing and other tools for doing the retrieval, and also some tools for calculating some metrics. So we'll start with the index repository. Here for this example, I already executed this code to index our repository because it takes some time. And I can show that here. Okay, so we are using open source to index our code repository. Also for the code repository, we cloned the open source repository from GitHub, and we will use that for our comparison. If we look at our index, it's called Beyond Grep code, and let's look at our first document. Here, for example, we extracted all the classes from our repository. This document just contains the whole class with this name. We also added some metadata like line start and end, and the content of the class here. Also, we used an embedding model which we run locally with Olama to generate the vector of the content of each class. So this document is a class document. Other document could be also methods. So we used some algorithm to extract relevant stuff from our code. It could be functions or annotations or even records or enum. And for this example, it's a function with this name. And here's the content of the function, and also here we generated the vector of the content of this function. So after that, we will try to do the comparison of the retrieval methods. So I will go back to the open source repository, and for the coding agent, we can use any coding agent. Here, for this example, I will try to use Codex. Okay, so I prepared a prompt just before in order not to lose very much time. So here in this prompt, I'll copy it here. I will ask the agent to run this tool from our MCP. So behind this tool, it will have two user queries with two different questions. And each question, he will try to solve it, not to solve it, just to do the retrieval with 3 or 4 retrieval methods. And also I told him for each question to show the question here, and after that to put the table, a table with all the metrics that we calculated. So I will run this query. Here first, it should look for the MCP, and it will try to call it. So here he called, I'll scroll a bit. Here we called this tool that I give him. And here we used limit of 5 just to get the top 5 hits for each method. And the question is here, he tried to use lexical search, then grep, then the other methods. And we can directly look at the results here. So let's take the first example, first question. Here we ask about a specific parameter in open source which is threshold enabled. So we are looking where it's defined. So here in the table we compared the 4 methods of search: grep, lexical, structural, and semantic. We can see that the grep has consumed much more token than the other, and also a bit slower. Although all of them are quick, but it's a bit slower from the rest. However, when we look at top results, we can see, for example, for Grep, it retrieved first, because we have no ranking in Grep, we had first an integration test. So maybe it's not very relevant to this question. We're not looking for tests. We just want to respond with the actual code. So this is Grep, and if we check the other one, we can see that the structural search, it gave us directly the right class from the very top hit. So we can see for this example, the structural search works the best between the other one. Eventually, the other one will find this class, but it will lose a bit of tokens before finding the right one. This is first example. If we look at the other question, the second one, here we are asking just a question without giving any hints or identifiers. So, for example, here we also see that the Grep has consumed the most tokens, and it was also the slowest. And again, here it retrieved the integration test at the beginning. And we see for this function, for this question, the only one that could solve it from the first hit was semantic search, which we can explain because it's a question in natural language. So here, I think we can, if we enter this class, we can see that they respond to the question about watermarks. So here for just for this numbers, here it's a rough estimation. So for the calculation, we took each character that the method retrieve as 4 tokens. It will consume 4 tokens from the quota of our agent. Okay, if we go back to the slides. Yeah, so this is a good coding agent should have this infrastructure, this loop. So an agent should take first the user task. It should interpret it, normalize it, analyze it, and after that it should do a search request on our indexed repository. And it can do some compiling test of the changes, and we have also a feedback loop. If anything fails or need to be corrected, he can do the search request again until it finds until it solve the user task, and at the end it will patch and generate our final code.
Yes. So the conclusions of this talk is that the retrieval is important for the coding agents and also for the LLMs in other contexts, because when the LLMs came out, everyone was saying, okay, we will replace search, we will replace developers, and we will replace also service as a software as a service. But in the last days, I think retrieval is a hot topic than ever before. We have always the same problems than before, but at a large scale, because we have more workloads. The agents do a lot of different requests at the same time. And even with bigger models, the clean context is still better than the large context. So we can just throw everything in a room, but if we have bigger room, we will just throw more mess in it instead of having a clean room. So it's not work like that. And we also, the most important takeaway here is that the model does not replace the retrieval. The model consumes the retrieval. So the retrieval is the eyes of the model, how the coding assistant will see the code and will read it and will understand it before doing his tasks. And the costs of token also are going higher, so fewer tokens are better with the right snippets than more tokens, and the agent, the coding agent still resolves the tasks even with fewer tokens. But unfortunately, it's not free. When you have retrieval, you also have costs of indexing and freshness, and you also need to maintain the graph. So in small repositories, it doesn't change everything to just throw everything in the context, but for larger repositories, sometimes it's efficient and it costs less the index, to have an index fresh and keep it every time updated than having a bigger model and just throwing everything in the context for each request and the cost go higher. So that's it. Thank you for your time. And if you have some questions.
Do we have any questions?
Hello. Wonderful talk. So you mentioned structural search, and I guess I'm wondering, because there's a few different ways that we can think of as structured code. What structure in particular were you using for this? Was it like a tree sitter, AST, or something like this?
For this demo, it is just an algorithm that we did ourselves just for this demonstration. So we extracted just functions from the code and classes and the enums.
Okay, so that's like a XML relation.
Yeah, but for production code, we should use a tool that
we wanted to use the AST parsers, but we didn't have much time. So
okay, well,
we will give the same talk at OpenSearchCon in North America in September, so we will have a better demo, of course, by then.
Yeah, I think I've seen some pretty compelling research that using AST and potentially other compiler IRs can enhance a reduction in token use.
Yes. Yeah. So this is what we wanted to use, but unfortunately we didn't have much time. But to parse for the demo, we just extracted the name of the methods, the reference to have just some links with metadata, but we didn't have used these methods. And we will also explore the Merkle trees so that we can just re-index just what changed and maybe use local files directly that changed it instead of re-indexing everything at each change. So yes.
Yeah. Okay. Wonderful talk. Thank you.
Thank you.
So thank you for the talk. So I personally also have been like experimenting with using structural search. Like there's an MCP server built into IntelliJ that can do the structural search, and it's also based on ASTs. And I find when I use it, it's very hard to tell the coding agents that it should use it. Because you can write your agents MD or whatever, and then it will most of the time use it. But in my experience, a lot of the time, the coding agents will fall back to grep anyway for some reason. So my question would be, how do I tell my coding agent how to use these search functions, and how do I tell it in what scenarios should it use which search function?
Yeah, great question. Thanks. We wanted to change the code of the Codex CLI that is open source and the Gemini also to try it. But for the demo, we only wanted to change only the retrieval part. So we didn't want to give other tools to the agent, and maybe he will use grep instead of our MCP functions. So this is why we did just an MCP, and in the prompt, we told him to use different methods and to compare them. But in general, the agent needs to have more tools in his dispositions instead of just grep today, or maybe some tools that we can enable. And he is very good at understanding the tasks, and I think he is better than us to understand sometimes the intent for search problem in general. So I think if we give him tools, and he is good enough to know which tools used to which use case, or maybe just use them as fallback. With grep, I will have a lot of noise. I will not find the good information. I will fall back to semantic search because this is more a natural language question. But we wanted to use the MCP just to change this part of the pipeline.
Thank you for your talk. The question I will have to you is whether you tested anything at scale, and if you have any observations of all of those retrieval methods? How do they behave, especially when your code base grows really, really large or its structure gets complex? What were some of the observations that you had from your experiments?
So we did not try it at large scale. Just for example, for the demo, we only did one repository. We tried on OpenSearch and Elasticsearch also because it's almost the same code before. The problem is that for indexing the semantic part on our computer, it takes very long. So in order to have always fresh index, it is complex. And also when the coding assistant changes the code, you always need to maintain this graph, so it's very complicated. We saw some talks of Ornet Dev at this conference. They are talking about search engine for the agents at this scale, so we can't wait to see what they are doing and have more information on it. But it's for sure that with our infrastructure and our workload, the workload is exploded with the agents. So challenging.
Thank you.
Okay. Thank you very much, Amine, Roudy.
Thank you.
Great talk.